Hi guys, it's Mrs. Frame. I just wanted to show you this really cool cubic function explorer calculator, point out some of the interesting things about it. Right now what's being displayed is the parent function. So if we take a look at this, you can see that we have y equals x cubed, and this is what that graph looks like. Now this is not a normal graph. If you look at your x-axis, it's going by 1. -1, -2, -3, -4. But if you look at your y-axis, we have a different situation going on. We have up to 5, 10, 15, 20. So it's not a perfect graph, but it's not a bother for what we're doing today. I just want you to take some notes. I want you to write down what the A term does, what the B term does, what the C term does, and what the D term does to the graph. Okay, so right now we're just going to look at the A term. We're not going to have any other terms. Notice my A is 1 and my B, C, and D are non-existent. Watch what happens when I take that number and bring it down. Let's see if I can get it to go. That's flat. That's y equals 0. I'm going to bring it down. Come on. There's the negative of the parent function. You notice that it's just the opposite of, if I take it back, there's the positive version. So you'll see if it's positive, the number 1 right here, it's coming up from negative infinity, flattening out, and then rising again. If I take it down to the negative and make it a negative, it's coming down from the positive and dropping down to the negative. So that's what the positive and negative does. Now let's look at what happens when the numbers get bigger. We'll make it a 2. Notice what happened. Got a skinnier, a 3, 4, 5. Okay, so you can see that it's making it narrow out. If I take it down to the negative, it does the same thing. The closer I get to -5, the skinnier it gets. Okay, and I can't get it to make fractions right now, but if I could, it would widen out, but we don't have that option with this applet. Okay, the next thing I want to talk about is the D. We know that this is our y-intercept. If I don't change anything, here's my parent function. You'll notice that as I go up and I go into positives, that parent function doesn't change what it looks like at all. It just slides up and down the y-axis. Okay, so that's what the constant, or the D term in this situation, does. Now let's look at what the x squared, the coefficient of your x squared does. Watch this. It's moving everything on the left of the graph as I go positive. And as I go negative, what is it doing? Looking pretty normal on the left, and then it's making a little wave on the right. So as I go positive number on my B, the left side changes drastically and the right stays the same. As I go negative on my B, the right side of the y-axis changes drastically. Okay, so that's what the B term does. Let's see what the C term does. C term, the higher the number is, the straighter the function becomes. The lower I go into more negative, the more like a wavelength it becomes. So you can see that the C term makes it look more like a wave the lower it is. Now let's see what happens if I make this negative. Notice that it's just sliding the right side down. If I make it positive, it's really making a difference on the left side of that y-axis. Okay, and so I just wanted you to see what the numbers do. Let me zero them out to your parent function here. And I will tell you that most of the time, guys, there's only 2 ways that you can graph this by hand. If you have an equation, let's say I put a -3x there and a 2, let's make it a -7x there. You'll notice that I have 1, 2, 3 real roots, and from this root to this root, I have what's called a parabola. And from this root to this root, there's another shape that's very similar to a parabola. And so these are the types that we're going to learn to be graphing this week. But as I said, there's only one way to do it perfectly, one way to graph these perfectly, and that's with a graphing calculator. But when you have to sketch things for a test, you've got to have some options. So either you've got to make a T-chart table and pick 7 points and hope you're sketching it out right. You can find your roots, which you know how to do, and your Y-intercept, and pick 3 or 4 more points. You might get a pretty good sketch. Or you're going to learn a little method that I'm going to teach you now, which will give you an even better opportunity, or get you even closer to getting that sketch to look as correct or accurate as possible. So let's go in and practice that. The next video is coming up.